I am Zeus.
Yeah, that was so sudden. Let me show you how did we get there. Today I'm gonna show you how I used graph theory to make these beautiful electricity effects. Okay, let's get into it. I'm using graph a lot in this video, so you must know the meaning of it. And before making a monster in your head, the graph is just some points which can be connected with some lines. God, I wish it could be that easy in the university. And how a graph can lead to these beautiful results that you saw, I'm gonna explain to you step by step. Okay, let's start with the minimum shape possible. We have two nodes and a line between them. As you can see, one of them is following my mouse, but the other one is just jiggling around, doing nothing interesting. Let's have an attraction. Here's the points again, but this time the other point cannot leave the borders around my point. As you can see, I can pull it wherever I go. You can also see the jiggle amount, which is 50 pixels per frame, which is a little boring. Let's bring up the jiggle. Here's how it looks like with the jiggle being 160. And if I remove the debug shapes, you can see that it looks interesting already. As you saw, the second point is following the first point on my mouse. But what if we have a third point which is following the second point? And we can go on and make a chain reaction. Let's try it out. Here's how it looks like in 3 points. Let me turn down the jiggle. Okay, now it's better. They follow each other perfectly as I wanted to. Let's add some more points. Here's the results with 5 points. I like it so far. Let's see the real thing. It's good, but not chaotic as an electricity, right? There's actually 2 approaches for the chaotic movement. Let's see them one by one. Let's say this point is chasing this one, and when it gets more than the normal distance, it should get to the closest path inside the circle. But I want to change that with a 50-50% chance. 50% chance it goes here, and 50% chance it goes all the way to the other side of the circle. And here's how the bump out method look like. We can have a big amount of jiggle, for example, going somewhere like this, and then coming back to the circle. But there's a better approach. We can look at the parent point and find a random point on the circle around it. For example, we get here, so we move this point right here. And as simple as that, we get the maximum jiggle possible from moving the points around. And this will be the result. Feel free to share your ideas. Which one do you think is better? I personally enjoyed bump out more. Okay, let's see what else we can do. As you can see here, we have a single line of points, which we're wiggling around. But I want to add more lines, each of them starting from the mouse position as the root. Here's how it will look like with multiple lines, each starting from the mouse position. Just as always, I want to take one step further. If you look at this picture, you can see it's not only a line of points, it's a line which spreads into more lines of points. And that reminds me of binary tree graphs. Let me tell you what that means. As I told you, a graph is some points which are connected in any way possible with lines, but a tree is kind of a graph which doesn't have any loops inside it. A binary tree is a tree in which the maximum amount of lines attached to a point is 3. I want to start from the root and I have 3 possibilities for each point. Whether I active the left point, or I active the right point, or both of them. And we do the same thing for every active point until we reach the limit. And every time we do this, we get a random binary tree. So as you might guessed it, instead of using single line points, I'm gonna use binary tree points, which must be more realistic. Here's our tree and we're recreating it every frame. So for the end, I decided to have multiple trees and merge all of the knowledge that we acquired. And you will have time to hit the subscribe button if you don't want to lose the other algorithm adventures. And as always, keep yourself hydrated.
Ooh. Yeah. I am Zeus.
Peace.
Bye.